Okay, this is the DAWS valve right here, and instead of having it chained by a bunch of switches, instead I have a spring compressor here. Inside there's a spring that changes the spring rate on the ball of the DAWS valve. Here is the vacuum supply going through the restrictor. That's, I forget the size of it. It was just pulled off of a blog earlier. And this is the vacuum supply. That vacuum runs around down here. And that's the not wastegate, but that's the VNT controller. And here is the turbo boost. This is the intake manifold. And here you've got the pressure supply coming in to the DAWS valve. So the concept here is that when boost gets high enough to pop the ball valve, it floods the vacuum here, and then creates a positive pressure down to the VNT controller, which opens it up and makes the thing decrease boost. When the DAWS valve is closed, then it remains closed. That means it's within the operating range that we want, and instead the vacuum system goes through there and makes sure that the valves stay closed. So the theory is that they stay feathered somewhere in some operating range that maintains the desired pressure. The desired pressure is really determined directly by the spring compression here. As the throttle valve goes up, it tightens the pressure, setting the pressure higher. Right now it's tuned for about 17 psi at the max, and when I let off, it drops down to 2 psi roughly, and that is something I just measured with the Mighty Vac when it was static with the engine not running. So in theory, it looks like it should work great. In practice, let's see. So again, you have vacuum supply going up to here, and then running down to the wastegate or to the VNT controller, and then the boost pressure coming in here, gated by the DAWS ball valve, spring valve, and the spring valve's tension determined by the throttle.